a series of the form the sum at n equal to 0 to infinity of c sub n times x to the n is written as c sub 0 plus c1 times x plus c2 times x squared, so on and so forth, is a power series centered at 0, where x is called a variable, c sub n a constant, called a coefficient of the series. For each fixed x value, the series is a series of constants that we can test for convergence or divergence. A power series may converge for some value of x and diverge for some other value of x. The sum of the series is the function f of x equal x0 plus x1 times x plus x sub 2 times x squared. Note that here f of x is a polynomial with infinitely many terms. Now, a series of the form the sum of n sub n equals 0 to infinity of x sub n times x minus a to the n is a power series that is centered at a. So here you can see that there is a shift. If you remember your function, when you subtract into the x value, you shift it to the right. So here we get the center as a. Let's talk about convergence and divergence of a series. For what value of x is the series as at n equal 0 to infinity of n factorial times x to the n convergent? Okay. So let's first write that. Let's use the ratio test. In here we have a factorial. So let's try the ratio test. The limit at n approaches infinity of a sub n plus 1 divided by a sub n absolute value is called the limit at n approaches infinity of n plus 1 factorial times x to the n plus 1 divide n factorial times x to the n. So this equal to the limit at n approaches infinity of n plus 1 times the absolute value of x. And this go to infinity. Okay, so by the ratio test, the series diverge. So by the ratio test, the series diverge. When x is not 0. Okay, when x is not 0, then the limit go to infinity. What happened when x equal to 0? When x equal to 0, then this limit go to 0. So then the ratio test, by the ratio test, this series will converge when x equal to 0. Okay, so here in this case, well, the series converge for some value of x and diverge for some other value of x, as we can see. For what value of x did the series convergent? Yeah, we want to figure that out. So here we have the sum from n equals 0 to infinity of x minus 3 to the n divided by n. So first, let's go take a look at the ratio test. So the limit at n approaches infinity of the absolute value of x minus 3 to the n plus 1 divide n plus 1 multiply with n divide by x minus 3 to the n. So I can simplify this. This is the limit that n approaches infinity of x minus 3 divided by and we can't simplify that, right? So this is n divided by m plus 1. But we can take the limit by multiply the numerator and the denominator by 1 over n. So then here we have x minus 3 divided by 1 plus 1 over n. So what happened as n approaches infinity? As n approaches infinity, then this limit here is just, then we will have, that make this, as n approaches infinity, this is equal to x minus 3. Right? So can we decide when does it converge or when it diverge? So by the condition of the ratio test, when x minus 3 is less than 0, is converge. Excuse me, less than 1. Then the series converge. So let's solve this inequality between x minus 3 less than 1 greater than negative 1. That implies 2 less than x less than 4. So then the series converge in the interval 2 to 4. Now, another thing with this though, when x minus 3 is greater than 0, then the series diverge. Excuse me, greater than 1. Solving this inequality, we can see that so then the series diverge in the interval from negative infinity to 2, union from 4 to infinity. Now, because we have the ratio test, we'll have to consider all 3 cases of the condition. So what happened when the absolute value of x minus 3 equal to 1? When x equal to minus 3 equal to 1, then x equal to or x equal to 4. So what happened at x equal 2 and what happened at x equal 4? If x equal to 4, so let's start with 2 first. If x equal to 2, then the series become n equals 0 to infinity of negative 1 to the n divided by n. So this series converge by alternating series test. Okay, so what happened if x equals 4? we get 1 to the n divided by n. And this is the harmonic. So this is the harmonic series, which is diverged. So in the end, to conclude where does the series converge? Well, therefore, the series converge. And this is the series in the question, n equals 0 to infinity, the x minus 3 to the n divided by n converge in the interval we include in 2 and exclude in 4. Consider the power series that have center at A. The series satisfies exactly one of the following property. The series converge at x equals A and diverge for all x that is not A. The series converge for all real number x. There is a real number r greater than 0 such that the series converge if x minus a less than r and diverge if x minus a greater than r. At the value where x minus a equal r, the series may converge or diverge. The number r in the third case is called the radius of convergence of the power series. So let's put this into a picture. So here you have a number line. Here's A, the center of the series. And let's take a look at this as A minus R, that's the radius of convergence, and this is A plus R. So then the series is converged here for x minus A is less than R and is diverged here for x minus A is greater than R. Again, we have to consider a separate case. What happened when at x equal A minus R and what happened at x equal to A plus R? Or, excuse me, what exactly happened at x minus A equal to R? Now, the proof for this is given in your book. So this is in 6.1 convergence in power series. And the proof is provided. So read that and let me know if you have questions or if you want to go over it a little more in detail. Let's take a look at this problem. Find the radius of convergence and the interval of convergence for the series. We will start with the ratio test. So I'll go ahead and calculate A n plus 1 divided by A sub n. And we talk about the limit after, is equal to 3 to the n times x to the n. Since we're going to be doing the absolute value anyway, so we go ahead and drop the negative. Or just include it, it doesn't matter. When include it. So a sub n plus 1 will be negative 3 to the n plus 1 times x to the n divided by square root of n plus 2. Divide and then multiply with the reciprocal, n plus 1, negative 3 to the n, x to the n. Okay. This simplifies to negative 3x times square root of n plus 1 divided by n plus 2. Okay. So as n approaches infinity, and I'll call this star, star become absolute value of negative 3x that equal to 3 times absolute value of x. Now, again, we use the ratio test. So let's consider our cases. First one, 3 absolute value of x is less than 1. Okay, this is where it converts. That implies absolute value of x is less than 1/3. Okay, so then this means x is in the interval of negative 1/3 to 1/3, and this is where it converts. Second case, when 3x greater than 1, this means absolute value of x is greater than 1/3. So x is in the interval from negative infinity to negative 1/3 union with 1/3 to infinity. This is where the series diverges. The third case is when 3 times x is equal to 1. This means when x equal to negative 1/3 and when x equal to 1/3. So let's consider to the series. What happens when x equal to negative 1/3? When x equal to 1/3, the series become n equals 0 to infinity of negative 3 times negative 1/3 to the n divided by square root of n plus 1. This simplifies to 1 over root of n plus 1. So this is divergent by the p-series. This is a divergent p-series. When x equal to positive 1/3, then we have n equal to 0 to infinity of negative 3 times 1 over 3 to the n root of n plus 1. This is n equals 0 to infinity negative 1 to the n divided by root of n plus 1. And this series converts by the alternating series test. So therefore, the interval of convergence convergence series when x is in the interval of negative 1/3, 1/3, and we include one of the endpoints, the radius of convergence is r equal 1/3. So in the previous example, we are given the series to begin with. Now, in the next problem, we are given a function, and we want to express this function as the power of the series, and then we want to find the interval of convergence. Okay, so given f of x equal to and this should say 1 plus x square, the square is inside, 1 over 1 plus x square. You remember the geometric series, I can rewrite this as 1 over 1 minus negative x square. Then this can be expressed as the sum at n equals 0 to infinity of negative x squared to the n. And I can rewrite this as the sum at n equals 0 to infinity of negative 1 to the n times x to the 2n. Okay. Like I said earlier, this is a geometric series. Because it is a geometric series, it converges when negative x squared less than 1, or when x squared is less than 1. If this is the case, then the interval of convergence is from negative 1 to 1. Okay. Now, what happens when we want to find the power series representation of x to the third divided by x plus 2? So let's write this down. We'll start with f of x equal x to the third divided by x plus 2. I can rewrite this as x to the third divided by 2 times 1 plus x. So this is x to the third divided by 2 times 1 minus negative x. So here we see that we have this written as x to the third divided by 2 times 1 divided by 1 minus negative x. I can rewrite this as the power series at n equal to 0 to infinity of x to the third divided by 2 times x to the n times negative x to the n. So this is the same as the sum from n equal to 0 to infinity of negative 1 to the n times x to the n plus 3 divided by 2.